All right, we are going to go ahead and finish up the EOC practice test part 2, questions 51 through 60. Hopefully I can get us through this before the next bell rings. All right, so number 51 on the workspace says graph a parabola and a line on the same graph. Pretty simple. Draw a graph. Draw a parabola. Draw a straight line. That's all they're asking for. And I have a feeling when we get over to the test questions, they're going to ask us how do you find the solution? So let's go see. Consider the graph shown at the right. Which function does the graph represent? Okay, I see what they're looking at. So on that other one, they weren't real clear on the directions, but we did what it said. So anyway, what they wanted you to recognize is that this is a parabola and this is a straight line. Okay, so they want us to find what function represents the one on the right. So let's take a look at everything that we do know, okay? Remember, open dot is greater than or less than. I probably shouldn't have it like that. That looks like 0. Greater than or less than is an open dot. Greater than, equal to, less than, or equal to is a closed dot. So we can see right here, we have a point on 1 and it's an open dot. So we know just by looking at that it is and then the line goes this way. So it's greater than 1. So our function, sorry you guys, losing my mind here, is going to be x is greater than 1. So x is greater than 1. That's for our line. That's for our linear function, okay? Our parabola is going to be a quadratic, so it's going to be x squared. And you can see our vertex is on 0, 0. So that's just our regular parent graph for a quadratic. So that's on x squared, okay? So our quadratic is x squared. So far we can't eliminate any of those. Our quadratic is also x is less than 1 because it goes that way. So again, we can't eliminate any of our answers because they all say that. So it's going to be up to the straight line to figure out what the correct answer is. So we could find our slope. On here, I go from this point here to this point here. I go up 1 over 1, 2, 3. So my slope is 1/3. Rise over run, up 1 over 3. Our y-intercept doesn't show on here. There's no y-intercept, but if you were to extend the line this way, you would see it's between 0 and 1. So look at our answer choices over here. Okay, we know it's not going to be A or C because we said our slope is 1 over 3. And then we said our y-intercept, if we had extended that, it would be between 0 and 1, which would be a fraction. And the only one when I'm saying, I'm talking about y equals mx plus b. That's why I was looking for this information. M is the slope, b is the y-intercept. So that's what we were looking for. So B has 1/3, and so does D as the slope. But then when you look at the y-intercept, the only one that's a fraction is B. So B would be our answer. Number 52. Given a polynomial graph, identify the zeros. So remember, your zeros are where our graph crosses the x-axis. This is kind of blurry, but we have one here at 3. We have one here at 2. We have one here at -4. So our zeros. Sorry, guys, give me just a second. My thing's stuck here. -4, 2, 3. Nope, that's not right. Okay, so that's number 52. Yeah. So they want us to consider the graph shown at the right, which equation represents the graph. So first we're going to find the zeros. We have one here at -1. We have one here at 2. We have one here at 3. Now remember, those are our zeros. Our factors are the opposite. So we would have an x plus 1, x minus 2, and x minus 3. Okay. Look over at the left. This first one has an x minus 1. Eliminate that. Next one has a negative x minus 1. And x plus 3 and an x plus 2. That's not correct. Next one, x plus 1 is correct. X minus 3 is good. X minus 2 is good. C should be your answer. Let's double check D just to make sure. Again, note that has a negative in the front. So we can eliminate D. We are almost at the finish line. 53. Given a graph, discuss where it is increasing, decreasing, and constant. Okay, so increasing. Oh, how did that happen? Trying to lay this down so I can write. Increasing. When x values are increasing, y values are increasing. Decreasing. As x values increase, Y values decrease. An example of that would be a line that's going like this. So your X values are increasing, but your Y values are decreasing. Constant. Values do not vary regardless of input. Okay. If you have room here, you could draw it here. Otherwise, actually, I'll show you. I'm going to draw it down here on the bottom. I'm going to draw a graph to show you what this looks like. So just like we had on that one before, we've got part of a parabola and then a straight line. Okay, so here, it's decreasing. Here, it's increasing. Straight line across is constant. Okay, you should go back up here and make yourself a little note, a little asterisk. See graph below. All right, now we're going to come back over here to number 53. Leo left his home and walked 5 blocks to his friend's house, as shown in the graph. What is one possible interpretation of the section of the graph? From point C to point D. Okay, so this is talking about on the left-hand side is distance from Leo's home. On the bottom is your time in minutes. Okay, so from A to B, you could tell he was walking. Took 4 minutes to get from point zero, from 0 blocks to 4 blocks. From B to C, he was walking again because he went from 2 blocks to 4 blocks in another 2 minutes. But from C to D is constant. So from C to D, he stayed 4 blocks away. He didn't move. He didn't go further away. He didn't turn around and go back for 4 minutes, or from 6 minutes to 12 minutes. For 6 minutes, he stood still. So that's what we're looking for, is it said, what is one possible interpretation of the section from graph point C to point D? A, he arrived at his friend's house and spent the day. Well, I'm going to say no, because he's still, after that 6 minutes, he keeps going. So that wouldn't be it. He returned home to get his baseball glove. Well, if he returned home to get his baseball glove, our graph would have went back this way and then back up as he left again. So no. Oh, what am I doing? I was trying to erase this. There we go. See, Leo waited before crossing a busy intersection. That's possible because he stayed in the same place and he just waited. Like, he was just there. He didn't go anywhere. So that one's possible. I'm going to check that one. We're going to go and continue to D. So it says he reached the top of the hill and began walking on ground level. This doesn't talk about the height of the ground. It talks about the distance from the house, distance and time. So whether it's a hill or not is irrelevant. So we're going to eliminate D. C is your answer for 53. Number 54. 54, 57, 58. We need to know the parts of a box plot. So 54, first we're going to draw ourselves a box plot. Box and whisker. Okay, remember we need 5 pieces of information for a box and whisker plot. Sorry, this shouldn't be arrows. Okay, now we can do. This here is our minimum. Here is our first quartile. Line here is our median. This line here is our third quartile. And this one here is our maximum. Five values needed. Minimum. First, or remember it's also called lower quartile. Median. Third, or upper quartile. And maximum. All right, so keep this handy because I don't want to keep flipping back and forth for 54, 57, and 58. We're going to complete those 3 in an effort to save some time. 54. What percent of a data set is represented in Q1 of the box plot? So remember that quarter 1 is, say you have a set of numbers here, then you have the median number here, you have another set of numbers here. Okay, that Q1 is the median of this set. Okay, so that first set of data is 25%. You can see it breaks it down into 1, 2, 3, 4 sets. So it's 25. I don't know why I switched to blue. I need to be doing this in red so it matches y'all's red pens. So it's 25. That also goes with 57 and 58. So I'm going to skip over to 57 and 58. 57 says an equal number of men and women were randomly selected and asked how many hours per week they spend exercising. The results are shown in the box plot below. The interquartile range for men is, so we've got I think that's 8 and 3, or 8 minus 5 is 3. This is 8 minus 6 is 2. Remember, that's the interquartile range. you're subtracting Q3 minus Q1, and that's how you get it. Okay, so the interquartile range for men is 3 is greater than 2. So it is greater than. Number 58. Amy is considering visiting her new friend at one of his beach houses in Florida. She really loves the warm weather, so she would like to choose to go somewhere with a high median temperature and a small interquartile range. Which place should she choose to visit? All right, so remember this line is our median, so let's figure that out first. So this one is, we're going to say it's about 76. This one's about 87. This one, and I'm using these number lines down here on the bottom. This one is approximately 78. This one is 85. And then a small interquartile range. This one I think is about 80. Maybe it's 81 minus 75. I'm gonna say it's 80. 80 minus 75 is 5. This one, about 94 minus 84. So that's 10. This one, about 81 and 77. So 81 minus 77, 4. And this one is about 87 to 82. Which is 5. All right. So let's go back and read the question again. It says she wants to go somewhere with a high median temperature and a small interquartile range. So our highest median temperature, well, we have 87, 76, 78, 85. Give me just a second, guys. I got someone at the door. Take a look at that. Sorry, I'm recording. Yay.
We got you a letter from students.
Aww.
We got you some bone rolls from Texas Roadhouse. And then we got you a gift from SGA.
You guys are awesome. Thank you. Appreciate it. Okay, sorry. So then we have the interquartile range for this one of 5. We have 5, 10, 5, and 4. So Destin does not have a small interquartile range. We can eliminate Destin. Destin has the highest, it's 10. Jacksonville, Fort Myers, and Pensacola are all right about the same as far as the IQR. It's 5, 4, and 5. So it said she wants a high median. So we've got Fort Myers at 76, Jacksonville at 78, Pensacola at 85. Pensacola has the highest median. And like I said, the other, the IQRs are about the same. So I'm going to go with Pensacola. $58. Oh, where did 58 go? Must have been on the other page. Oh, that was 58. Yay. That means we're one problem closer to the end. Number 55. Remember, we're going back to 55. we skipped around a little bit. So 55, know when to use the mean, median, or range. So mean, when you're looking for the average, looking for average. And remember, I said you can remember that as the average person is mean, the average teacher is mean, the average mom and dad is mean, whatever. Whatever's going to help you remember it. Median. Hopefully you'll know what those big cement things are in the middle of the road, separating the directions for traffic. It is a median. It's in the middle of the road. So you order values lowest to highest. And it will be the middle value in the list. IQR, oh, remember mode? I don't know why they don't have that listed on here, but let's do mode just in case. What in the world is going on here? Okay, let's try this again. Mode, most is the value that occurs the most, not the highest value, the value that occurs the most. IQR, the interquartile range, find your median. Calculate the median of upper and lower halves of data, and then find the difference between Q3 minus Q1. Okay, that is mean, median, mode, IQR. Go back over here and find number 55. There we go. The amount of money that high school students spend on fast food each month is usually between $50 and $200. However, there are a few students who do not eat fast food at all. What measure of spread would be most appropriate to measure the amount of money that high school students spend on fast food per month? So it says that, it doesn't say most, but it says the amount of money high school students spend is between 50 and 200. But then there's some that don't spend anything at all. Well, we're not going to want to use the mean because the mean is the average. So that the students who don't eat anything at all is going to bring it down. Or if we take that out, the 50 and 200 would bring it up. So that doesn't really, that's not a good indicator, I guess is the word. Range would be from 0 to 200. That's not good. Standard deviation, no. Our best bet is our interquartile range. So we would have our minimum of 0, our max of 200. We would find our median. You guys don't have to draw this. I'm just trying to explain it visually. Then you would take Q3 minus Q1, and that IQR is the best measure of spread. 56. Analyze a dot. Why can't I say these words? No, analyze a dot plot. Each value is represented with a dot, literally a dot, above the number line. A dot plot shows frequency of data values. Make sure you include the title and scale on the number line. It's used for smaller sets of data and discrete data. Make yourself a little asterisk. See example below. Because yes, we are going to draw a dot plot. And keep getting dot and box mixed together and saying docs or bot. All right, we're going to draw a number line. I'm going to say 0, 1, 2, 3, 4, 5, 6, 7, 8. Down here on the bottom is our number of books. Red. And then our dot is going to be, our dots are going to be our number of students. It is a reading frequency survey. Now, this is just an example. I'm not getting this information from anywhere. I'm just pretty much making it up. Okay, so we have 0 students read 0 books, so I'm not going to put a dot there. We have 1 student read 1 book. I've got 3 students that read 2 books, so I'm going to put 3 dots. I've got 4 students that read 3 books. I've got 5 students. Oh, I think I said 4 and I only did 3. I've got 5 students that read 4 books. I've got 4 students that read 4 books. I've got, sorry, 4 students that read 5 books. 2 students that read 6. 1 that read 7. And none that read 8. So that is a dot plot. It's just each student surveyed is represented by 1 dot. So here we go, number 56. Analyze the data. analyze the data sets below, which statement is false. So symmetric means it's pretty even, kind of like it's cut in the middle by a mirror and each side is pretty even. That's symmetric. Skewed left and skewed right is going to be kind of the opposite of what you think. So if you looked at data set B, this one here, I'm going to guess that if you had absolutely no idea what skewed left and skewed right was, you would guess that data set B is skewed left, okay? Because the dots are up here and it's more that way on the left. And that would be incorrect, okay? So I said it's the opposite, probably the opposite of what you think. So what you want to do is if you start at the beginning, draw a line. That way, it's actually skewed right. Okay, because our arrow goes that way. And it's bigger at this end here. If it was skewed left, our thing would go, we would go this way. Okay. So I'm going to say right off the bat that A is false. But I want to look and see the median, the middle number of A. You can see you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 numbers. So the median is going to be in the 2 in the middle. It's an even number, so it's the 10th and 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 29 and 30. 29 and 30 is 59. It's going to be 29.5. So that is correct. The median of A is 29.5. B, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Again, there's 20 there. So we need the 10th and 11th, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it's 27. Oh, it's looking for the mean, not the median. Okay, if we add all of these up, you get 559, 25 plus 25 plus 25 plus 26, 26, 26, 26. And then you divide the whole thing by 20, you get 559 divided by 20. And you do, in fact, get 27.95. So C is true. The value of Q1 in set A is 26. So remember, quarter one is 25% of the data, the first 25%. I got about 5 minutes. I got to rush this. And we had 20 numbers. So that's the first 5. So 1, 2, 3, 4, 5. It is actually 26. So that one is true. Again, we were looking for the one that was false. So the correct answer is A. See if we can get through 59 and 60 before this bell rings. Find the mean, median, and IQR. So this is asking how do we find it? So mean, add all values together. Then divide. Gotta stop trying to write fast. When you rush, things actually take longer. Then divide by number of values. Median. Order the values lowest to highest, the middle value in the list, IQR, we already wrote that. Find the median, it's right here. So we can just do that there. We already did that. Find the median, calculate the median of the upper and lower halves of data, find the difference between Q3 and Q1. All right, let's go see if we can get these last two in. The following numerically ordered sequence of numbers has a mean of 17 and a median of 18. Given this information, the values of A and B must be. So you can plug all of these in and divide. So if this was 9 and this was 18, add those all up real quick, see if we can get. Actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So 17. Just by looking at this, we have two middle numbers, and it tells you your median is 18. So if one of the middle numbers is 17, it only makes, if the median is 18, it only makes sense that B is 19. Okay, so the only one that has B is 19. This is saving you a whole lot of work. The answer is D. Okay, so you could do that as 17 plus X divided by 2 equals 18. Yeah, because then you would multiply both sides by 2. You would get 17 plus X equals 36. Subtract 17 from both sides, you get X is equal to 19. Okay, so you could see that the median for that, or that the numbers are 9 and 19. Okay, number 20 or 60, there are 25 students in Mr. Ventosi's class at the beginning of the school year, and the average number of siblings for each student is 3. A new student with 8 siblings joins the class in November. What is the new class average for the number of siblings? Round your answer to the nearest hundredth. So we have 25. I'm going to say times 3 is 75 plus 8 for that new student is 83. I'm just kind of talking to myself here. Yep. So we had, it said average number for 25 students was 3. So I took 25 times 3. I got 75. Then they added one more student that had 8 siblings. So I took that 75, I added those 8 siblings, and I got 83. We now have 26 students in the class. So take 83, divide by 26, you get 3.19, and that is the new average. All right, that's it. Now go rewrite all of this on regular paper. See you guys later.